Good day everyone, this is Mr. Arias and today I will now tackle the second type of collision, in particular, inelastic collisions. Okay, so for inelastic collisions, remember that this is when two objects collide and then after the collision they stick together. Okay, and in that case, if they stick together, then the formula for inelastic collisions would look like so. Okay, so you've got M1. Okay, so that's M1 V1 plus M2 V2. They have separate masses and separate velocities at the start, and after the collision, momentum is conserved, but they stick together so that the masses are the same, or rather they add up. Okay, M1 plus M2 times Vf. Why? Because when they stick together, the masses combine, and Vf means that they go on the same velocity. Okay, so let's tackle this problem. So American football, a 95 kilogram fullback running at 8.20 meters per second collides in midair with a 128 kilogram defensive tackle moving in the opposite direction. Now, if both players end up with zero speed, determine the initial velocity of the defensive tackle. Okay, so what are we given in this problem? Okay, so we are given the masses of the players. Okay, so let me put that down. So before the collision, okay, you've got one player moving on one direction and the other player approaching the other player head on. Okay, the mass of one player is 95 kilograms. Okay, and this particular player is also moving at a velocity of 8.20 meters per second. Okay, now let's take a look at the other player. Now, the other player has a mass of 128 kilograms, and the velocity of the second player, well, that is something that you don't know and you are attempting to solve. Okay, so after the collision, it is said that the two players stick together and drop to the ground at rest. Okay, so that's what I imagine it to be. All right, so they stick together. So with that, M1 and M2 will combine, and the Vf is said to be zero because they stick together and they collapse to the ground. So what you're really looking for here is V2, or the velocity of the defensive tackle, the heavier player. And in terms of equations, let's just use the one that I wrote up top, which is M1 V1 plus M2 V2 is equal to M1 plus M2 times Vf. Okay, so in terms of solving it, the idea here is to isolate V2. So let's take a look. So M1, okay, sorry, my bad. That's not what it is. I'm also imperfect, by the way. So M1 V1 plus M2 V2 is equal to, parenthesis, M1 plus M2 Vf. But you know that Vf is equal to 0. Okay, we've defined it to be 0, and therefore this entire right side of the equation can cancel out as 0. So you're just simply going to be left with, okay, M1 V1 plus M2 V2 is equal to 0. Okay, so with that, we can now tinker with this equation in order to get V2. Okay, so it will become M2 V2 is equal to, if we transfer M1 V1 to the other side, it becomes negative M1 V1. Okay, so now we just have to divide both sides by M2 to get negative M1 V1 all over M2. Okay, so now we have an equation by which we can plug and play all of our known values to solve for the unknown V2. Okay, so let's do it. So M1, okay, so there's a negative, but M1 is 95 kilograms, okay, times the velocity 1, 8.20 meters per second, okay, but negative, okay, all over M2, which is 128 kilograms. All right, so now let's get our calculator out, plug and play, get the fraction, okay, 95 or negative 95, okay, times 8.20 all over 128 gives me 6.0859375, but taking note of the fact that there's a negative sign, so it becomes negative, okay, 6.08, okay, let's complete it, 59 375 meters per second. Okay? So negative meaning that it makes sense because your fullback, or rather the defensive tackle rather, is going to the right, which is a negative speed. So V2 is equal to negative, when considering significant figures, okay, 3 sig figs, so negative 6.09 meters per second. Okay, so that's how we solve for inelastic collisions. So important to take note of that they combine masses at the end and that their final velocities are equal at the end because they're the same mass, the same body, and that's it. Okay, so for the next one, we will tackle explosions. Take care and goodbye.